We talk about it now? All right, so if I ask you about number one, what type of radiation can we use? Alpha. What can stop beta decay? Aluminum foil. What's the symbol for alpha radiation? The Jesus fish is not going to be the answer on the test. That's what you need to be able to recognize.
How did you say that?
Helium. A helium nucleus.
So it's not the fish?
Not the fish. The helium nucleus that you're going to need to know. Okay? All right, and filling in the two balanced equations that you have up there, you have a mass of what on the left? 234. So what do you need to fill in the blank line on the right? I heard it. That's a sorry, pitiful voice I hear out there. That sounds so much louder. Thank you, Alex. 230. All right, what atomic number do I need on the bottom? 88. So what element do I put there? Sleep? That's not an element. All right, what element goes there? R who? Ra. All right, and on the bottom? She said Ra, so I wrote it down. I hope it's right. Oh, let me write it above the line. Okay, and for the second one, what atomic mass do I need? 244. All right, and on the bottom, I need 95. And what element would that be? Who? AM. Okay, everybody good with us?
I thought it said 220.
Okay, if I was to ask what type of nuclear decay we have in the first one, what type would you tell me? Alpha. All right, how do we know it's alpha? That's helium. And what type of decay do we have in the bottom? Because you have a, everybody okay with that? Okay.
So when it asks for the symbol, we don't need to know the Y and the fish and the
No.
B.
The only one you might see with the Y would be gamma. I don't think you'll see the Jesus fish or the B for beta.
How did you know it was beta?
Huh? You know it's beta because it has the E right there. And that's the symbol for the beta. Okay? Any other questions? All right, let's run through your homework sheet real quick, see if you have any questions, and then we're going to move on to review. All right, we'll start on the side that had the questions, then we'll do the equation second. All right, in question one, it asks you about which particle will pass through a magnetic field. In a magnetic field, you have positive and negative charges. So thinking back to what you learned in another science class, what happens with charges? Do opposites attract or do same charges attract? Opposites attract. So positives attract negatives, negatives attract positives. What happens when you have two negatives? They repel each other. They move away from one another. Two positives will also repel each other, right? All right, so thinking about that. What do we know about an alpha particle? It's what charge? I heard it out there. It's positive. Beta particle is negative. And a gamma particle is what? It doesn't have a charge. Before I forget, come get my keys. Unlock the computer cart back there. Leave the lock on the top. Get your laptop. And you need to do the tutorial so I can finally turn in this piece of paper on my desk. I'm not going to let her write her name and say she did it. You need the keys to unlock the cart. I know it's too early. You need a second shift job, by the way, when you are an adult. Third shift might be a good plan too. All right, so if you have a question that says it's not deflected by the magnetic field, it's saying it passes directly through the field, okay? It's not attracted, it's not repelled, it just passes straight through. So what particle is not going to be attracted or repelled? Gamma, okay? Okay, did you guess right? Oh. What's the weakest type of radiation? Alpha. When passed through a magnetic field, it's deflected towards the negative pole. All right, who's going towards the negative? Alpha, because positives go towards negatives. Okay, that's why I asked those questions a minute ago. All right, alpha will go towards the negative. Number 4, it's formed when a neutron in the nucleus breaks apart. Who? Beta. Okay. When passed through a magnetic field, it's deflected towards the positive magnetic pole. You want me to set that up? Or you know where you're going?
I just NC tested.
Yeah, do you know how? Okay. And then show it to me so I can see that you're doing it. All right. Who goes towards the positive pole? Beta. Good. All right. Who's the most penetrating type of radiation? Gamma. All right. Who's a helium nucleus? Alpha. Which one's the electromagnetic wave? Who? Gamma. The wave is gamma. All right. Who can be stopped by a sheet of paper? Hold on. Hold on. I need to make sure my son has right on this afternoon. One of these texted me illegally at school.
At least it's I was about to say.
Oh, no, he's
I have to show them.
online reading, the dress got where she,
I'm doing
another where she
2 weeks if I did.
reached out to her 4 times.
Right, they don't have to be right.
I know.
Mine would go my way, and something with my business, you know, she's.
I'm not doing all
That's
that.
why I don't know where it is, like, I don't know.
You didn't have to change your skin.
Which I never got. And then he reached out to me. Shut up.
I should take care of that. All right. So where were we?
He finished.
Okay. Put in the thing. You do know you can't have green.
I told her that.
Stop by, she.
I'm not setting up 75 computers in green,
Oh, I know.
yellow, black. Oh, okay. Okay. I'm just not going to pre-do that by Monday for y'all. Okay. And now I need you to sign a piece of paper up here on my desk as you pass by. It says you did the tutorial. Initial, and then put your laptop away. Because you're the last one I'm worried about chasing down. Anybody else? Tough noogies at this point. All right. So which one did we stop on? Number 9. Can we stop by a sheet of paper? Alpha consists of 2 protons and 2 neutrons. Alpha, the helium nucleus. Remember, if you have He with a 4 and a 2, what does the 2 represent? 2 protons. How do you find neutrons? Subtract the 4 and the 2. That's where the 2 neutrons come from. Is an electron. Okay? So beta is an electron and can pass through several centimeters of lead. Gamma. It's the only one that can go through lead. All right. For the
Wait, what was the letter?
11 was beta. All right. So for the back side, rather than call out answers.
Why not just call out the answer?
No, because I'll have to repeat them 800 times. I know y'all.
You will.
So,
Oh, you don't put another one?
Yep.
Oh, I thought you was gonna do it like this.
no. I do not have stupid stamp on my forehead. Some days I feel it. All right, now slide it up in a minute. For those of you who did it, those are the answers. Check to see if you got them right. I'm not going to leave it up there very long.
Is that RN for 5?
For 5, yeah, it's RN. Now, if you look at 11 and 12, see how it says plus gamma raised? All right, gamma has no effect on balancing or writing the equations. Gamma is just sort of written at the end of the equation like that. Okay, so it doesn't affect how you write or balance a nuclear decay equation.
So on number 9, like I put, I wrote 202 and then 80.
That's what I put.
How do you know, like, you just look for which two, like, elements are grouped together?
What do you mean you wrote 202 and 80?
Because I thought it was,
She know one was 202, was 206.
then 80 must do 82.
Huh?
You didn't know that?
Oh,
I see it.
Oh, the arrow is essentially an equal sign. So whatever is on this side has to equal what's on this side. So it says these two are both on the same side. They have to equal whatever's on this side. Does that make sense?
Yeah.
Okay.
That's PO.
Yeah, that's PO. Cold tonight? Are you cold? Okay. Say it hadn't even got to the point that they're blowing cold air on us yet. You're gonna freeze by in about an hour. Yeah, it usually gets colder about an hour from
You
now.
know the algorithm?
Hour and 10 minutes. All right. Everybody
Can you
good?
take a 10-minute nap?
Nope.
Then you leave us
All right. If you will, find your practice test that I gave you. I don't know if it's good news or bad news for some of you, but the state has released 40 more questions. So I have some more current questions from the state exam.
But we're not going to do this, right?
I'm giving them to you. I don't care if you do them or not. It's your test, it's your grade. I'm an equal opportunity A, B, C, D, F giver. It's your average. It's your grade.
You are so supportive. Thank you.
You get what you earn. You don't do your part, you get what you get. It's that simple. You get what you put into it. The more you put in, the higher your grade. The less you put in, the lower your grade. The exam is very doable. Now, when you look at the question that's up there, Lolly asked me yesterday when you see something about isotopes. The answer that I would likely give is probably. Now, will you have to calculate an atomic mass with isotopes? I sincerely doubt it. Okay? What things should you be able to do with isotopes? You should know what isotopes are, and you should be able to find protons, neutrons, and electrons. So, what has to be the same for an isotope? Okay? If you don't know it, write it down on your test booklet. Odds are good for the vast majority of you. You're not going back to look at a semester's worth of work on Sunday. Okay? Some of you are not going to study at all. You might look at a couple pages on a test booklet. So write it down. So at least you got some key facts to look at. All right? They'll have the same protons. What's another way to say the same protons? Same atomic number. All right, what has to be different to be an isotope? The mass or the neutrons. Okay, you have different neutrons or different mass. Okay, that's the key to being an isotope. So when you look at right here, okay, it says, how are these isotopes alike? Now, it just gave you a basic definition there. They have the same number of what?
Protons.
Same number of protons and the same. So which one has to be the right answer? C. Now, number 2. Which statement correctly compares the atom of boron 11 and the atom of boron 14? All right, when you look at the answers, it's talking about 1 fewer proton, 2 fewer neutrons. Well, does it give you the protons or neutrons in that question?
No.
So what's the first thing I'd do? I'd figure out my protons and my neutrons using the periodic table before I did anything else, okay? So, you guys are going to have scrap paper. Don't do like one of my students in 4th period who says, I did it off the dome this fall. All right? You have paper. Write down the stuff on the piece of paper and figure it out. If you had a test booklet back in the day, you'd have written it all over the test booklet.
Yeah, I hate how we all.
I hate that you have computers too. I so wish we were still doing it on paper, but we're not. So use the scrap paper and figure it out. So if you had boron 11, what do you have to look up on a periodic table? You should have a periodic table in your reference tables in front of you today, by the way, so you can reference them and look this stuff up if you haven't already done it. Okay? So boron 11 has how many protons?
5.
5. Okay? So it has an atomic number of 5. So the protons are 5. All right? Now, the question says neutrons, so we need to find the neutrons. How many neutrons does it have? How'd you get it? So some people might not know. 11 minus 5 is 6. Okay? So we've got 5 protons, 6 neutrons. So carbon 14. What's its atomic number?
6.
Okay? So how many protons does it have?
8. No. 6.
Has 6 protons. How do I find the neutrons?
Subtract 14.
14 minus 6. Anybody have a question on how Chris did that? Okay. Sorry, can't make that 14 look any better. So we have 6 and 8, and we have 5 and 6. So now that we know the protons and the neutrons, now we can read our answer choices. So an atom of boron 11 has 1 fewer proton. Boron 11 has 5 protons and 6 protons. Does it have 1 fewer? Yeah. Has 2 fewer neutrons. We have 5 neutrons, 8 neutrons. Does it have 2 fewer neutrons than an atom of carbon 14?
Yeah.
Yeah, that looks like the answer.
Wait, hold on. You said that we had 5. Did you say that wrong?
I may have.
Okay.
All right, so an atom of boron 11 has 1 fewer proton and 2 fewer neutrons than carbon 14.
You said 5. Boron 11 has 6 neutrons, right?
Yeah.
And 8. 8.
Okay, so we have boron 11 has 1 fewer proton because it has 5 versus 6, and 2 fewer neutrons because it has 6 versus 8. So does it have 1 fewer proton and 2 fewer neutrons?
Yes.
I think it does, but let's read the other answers and see. So an atom of boron, and I would always read all 4 answers. An atom of boron 11 has 1 fewer neutron and 2 fewer protons. Does it have 1 fewer neutron? No. 6 to 8 is no. An atom of boron 11 has 1 fewer proton and 3 fewer neutrons. No, because it's got 2. An atom of boron 11 has 1 fewer neutron. No, it has 2. So the answer is A. All right, 3. Here you go with an electron configuration. We talked about this yesterday in Blitz. Y'all remember how to write electron configurations? Yeah, are we supposed to? Yeah. You're supposed to be able to do it two ways, either with your arrow chart or using a periodic table.
I remember both.
That's good.
Do you have to remember?
I remember how to do it with the arrow.
Uh-uh. It doesn't matter which one you remember as long as you can do it. Okay? So if you're writing iron, iron has 26 electrons. So I don't care if you draw it with the diagonal arrows or if you read the periodic table as long as you know which one's correct. Okay? Either one's fine with me. Which answer did you pick? D is wrong. A is correct. All right, we need to talk about it since people pick D. One, two, three, four, five, six, seven. S is beside all of those. 2, 3, 4, 5, 6, 7. P's beside all of those. This chart's going to look really bad because I'm writing on Adobe. 3, 4, 5, 6, 7 with D's beside all of those. And then 4, 5, 6, 7 with F's beside all of those. Change my color here. Draw your diagonal lines. That's some jacked up mess. All right, so I got the top part right. All right, so first thing in our chart is on S. How many electrons can go on an S? How many? 2. After 1s comes 2s. How many can go on S? 2. After 2s comes 2p. How many can go in P? 6. Count your electrons. 2, 4, 10. I'm not at 26, so I got to keep going. What comes next? 3s. How many can go in S? 2. After 3s comes 3p. How many can go in P? 6. Next, 4s. How many can go in S? 2. We're at 20. What comes after 4s? Up here is what? 3d. Now, at that point, D can hold how many electrons, Jada?
Oh, sorry.
No kidding. D can hold how many electrons?
Oh, 8,
Mm-mm.
14.
10.
Oh.
D can hold 10. We're at 2, 4, 10, 12, 18, 20. I only want to go to 26. So if I want to go to 26, how many am I going to put here? I can put 10, but I only want to go to 26. This is number 20. So how many am I going to put there? 6. I'm going to put 6 there. That's why A is correct.
Oh,
Good.
so wait, the only difference between D and A is that the last one of D has a 4.
Mm-hmm.
Okay, that's what I was
Mhm. That 4 makes it wrong.
I didn't write the numbers on it, and then I just thought 4S would be 4, so 40.
Yep. That's what makes it wrong. All right. How many electrons are in the outermost energy level of aluminum? 3. Everybody okay with the short way to do that? You didn't draw the configuration, did you? You just looked at the periodic table and said 1, 2, 3, right? Okay. I'm sorry. Well, you can do it the long way, but I would hope you do it the easy way. Okay? Here's some. This is what you're more likely to see with the dual wave. Okay? I don't think you're going to see anything harder than this. All right, so which transition occurs when light with a wavelength of 434 nanometers is emitted from a hydrogen atom? Okay, so to do this, you got to go to your reference table. Come on, reference table. Look, let me get a test paper so I've got the question in front of me. .434. Come on, baby. Work. Get him up here. All All right, so 434 nanometers is right here, right? So go up. What dot's it on? 5. And it goes to what? 2. 5 to 2. Okay?
To the same line?
Okay. Everybody good with that? So the 434's bubble, or little circle, is right here. I erase that for a second. Little circle is right there. So that's on the 5 line, and the arrow points it to the 2 line. Okay? So now if I go back to the question, all right, it went from the 5 to the 2. Now, did it jump from 2 to 5, or did it go from 5 to 2? It went from 5 to 2. That's why it's D. All right, number 6 is what we just did yesterday.
Wait, so the dot will show like where it went, because that's what I struggled with. Like I found the 5 part,
Mm-hmm.
and I didn't know that it pointed to the 2.
Yes, it points to the 2. Wherever the arrow ends on is where it's pointing to. So, talk to me. Yes, because it's always going down. Okay, if it asks you about the energy because it's going down, would it be released or absorbed? Released, or you can say emitted. Yes. Okay?
Okay.
If it asks you what color is the light for 434? How would we do that? If it asks you the color of light,
Would it be blue?
what color is the light?
Look like?
No,
It'd be blue.
be 4.34. And where does 4.34 fall on this line?
Blue.
Yep, 4.34 falls there.
There was some chart we did that where you multiply by a number. Do you happen to know that? It was like you multiply by like 0.8, I can't remember. But it was with this. It was like how you convert it. With your
Calculating C equals lambda nu.
Yeah.
I don't think you will see that on the exam. I think it'll be more like what you just did right there. If I'm guessing. I usually guess pretty well. All right, number 6 is like what you did yesterday. Okay, suppose you have that equation and it wants to figure out x. So what do we do? If this is 222 on this side, you've got 4 plus what number has to go there? What? I heard it. 218. 2 plus what gives you 86? 2 here plus what will give us 86 over there? 84. Okay? So now we should be able to figure out the question. What's the mass number of the element represented by X? 218. So the answer is B. All right, number 7. All right, here we go with ionic bonds and metallic bonds. Some of us really struggled here with this concept. All right. This is some of the stuff that will cause the biggest headache for y'all because y'all hated bonding. All right, ionic and metallic substances. The bonds of metallic substances are composed of delocalized electrons. What does it mean when they say delocalized electrons? What? Delocalized means they're moving. They're not attached to anything. Okay, so if I put that word in, does that help us any?
Yeah.
Okay, so the bonds of metallic substances are composed of delocalized or moving electrons, and the bonds of ionic substances are composed of transferred electrons. The bonds of metallic substances are composed of isolated electrons, and ionic substances are composed of shared electrons.
Because I thought what it said isolated, like we said, it was donated to space or whatever.
Isolated? No. Isolated would not mean that. Isolated would mean stuck off by themselves. Like the child in 4th period yesterday who stood in the corner back there for 20 minutes because I don't know why. All right, that would be isolated. A metallic substance insulates heat and electricity, and solid ionic substances conduct heat and electricity. A metallic substance has a low melting point, and an ionic substance has a low melting point. All right, which one do you like? A is the right answer. All right, first of all, those of you who forgot, metallic, all right, has moving or delocalized electrons. Ionic has transferred or lost or gained electrons. Covalent has shared electrons. Those are the basics. Okay? That's the absolute minimum you need to know. Now, when it talks about these properties up here, who conducts heat and electricity? Okay? Now, I feel like today, Caroline and Antoinette and I are having and some Diamond are having a really good discussion. The rest of y'all, I don't even know y'all are in the room. And even Chris is a little dead over there today. All right, metallic conducts heat and electricity. All right, do ionic conduct heat and electricity? No, they don't. Okay, ionic, no heat or electricity. Now, you can get them in water and they'll conduct heat and electricity, but they're not doing it on their own. Okay? Metallic and ionic have a low melting point. Do they have low melting points? No. Okay? Metallic and ionic have high melting points. Who has the highest? Ionic or metallic has the highest? Who has the strongest bond? Metallic. Okay? Remember, metallic was the greatest, then ionic, then covalent. So metallic had the highest melting point, then ionic. But both of them were high melting points. Covalent has the lowest melting point. Okay? Now, that's just some basics to review. You with me, Elijah? Now, the next one should be an easy one for you to get right. What's the compound there?
L2S3.
Okay, just find the oxidation numbers on the chart. And I told you, write this on your periodic table when you get it. 3 for that one, 2 for that one. Bring your 2, bring your 3 down. Because it's going to be, when you open your chart, it's just going to open up into the middle. It's a giant periodic table. Caroline got mad yesterday when I told him you can't tear your chart apart, but you can write all over the charts, okay? So just write on it. Write anything you want to on it. Draw on it, but you can't rip it out. It's, first of all, it's attached, and it's the big center of your reference tables. State frowns on ripping your stuff apart.
Wait, so what are the exceptions? Like, I know, like, I can't remember, silver's like 2 or something. Like with the oxidation number.
Yeah, we just go to this one. All right, we did this the first day when we did Blitz. For those of you who were not here the first day.
Do you need time to draw on this chart?
Yep. Now, oxidation numbers. Here's some basic rules for writing compound names. It'll make life easier for you. Now, everybody knows the basics for oxidation numbers. Nobody's having any trouble with that at this point. If you are having trouble with it, it's sort of like balancing. At this point, I don't want to know. Okay? No, I don't. Okay? 2 days before the exam, I need to believe that everybody can find the basic oxidation numbers. Okay? If you can't tell me those oxidation numbers today, I really need to believe you can.
I do have a question.
Yeah. Okay.
Nitride.
Huh?
Nitride.
Nitride. Okay.
3, right?
Yeah. Because it's in group 15.
Oh.
Yeah. Okay. Now, the thing I want to point out is you don't have an oxidation sheet to find Roman numbers, right? So you don't know who gets a Roman number and who doesn't get a Roman number. All right. no Roman numerals. Group 1, 2, zinc, silver, and aluminum. Every other element on the periodic table is going to have a Roman number. Okay? And that's because these elements never have more than one oxidation number. Now, to answer Caroline's question, she asked about the transition metals and what their oxidation numbers were. Who remembers zinc's oxidation number? It's +2. Now, silver's is what? Jada? That's the one. All right. And aluminum's. That's +3. Okay. Group 1 is always what? It's always +1. Group 2 is always what? +2. Now, if you're not in group 1, if you're not in group 2, or you're not one of those three people there, zinc, silver, or aluminum, you must either give someone a Roman number or you have to write a Roman number. Okay? These are the only people who don't get a Roman number. Now, it'll either be a stock system or it will have a prefix. So yes. Okay? If they use the letters, write it with IUPAC convention. That is what we've used all semester. So don't let that throw you off. Okay? Any questions about that? Okay. So if we go back to our question, which one's likely to be ionic? What do you look for to be ionic?
Metal and non.
Okay, so who's the metal and the non? Okay, so anybody who might not have known that, just a quick covalent would have to be a what? What? Non-metals. And metallic would have to be what? Just a metal. One metal. Okay? They're not going to try to trip you up. They're going to give you a singular metal if they're trying to give you a metallic bond on the test. Okay? They'll say like nickel. They'll say iron. They might be tricky and say sterling silver, which is an alloy, and give you something like that. And they might say brass, but they're not going to give you aluminum nickel. Okay? They're not going to try to combine two metals. It'll probably be a singular metal. All right. Now, this one kills me. Which is an accurate comparison of the bonds that can occur between carbon atoms in terms of bond length and strength? Who did we say was the longest, shortest, strongest, whatever? Who are the longest?
Single bonds are long.
Single is the longest.
But it's easiest to break.
Triple is the shortest.
It's the hardest to break.
Okay, so that makes triple the strongest, and that makes single the weakest. Okay, we only spent 5 minutes on it.
I remember the strong and the weak, I just don't remember the longest.
Okay, broke a pencil or a colored pencil. All right, so which one would be accurate given that description? B, triple bonds are shorter than double bonds, yes. And double bonds are stronger than single bonds, yes. That is correct. All right, number 11, which represents the formula for iron 3 chromate. Yep. Iron has a Roman number here. Remember, the Roman number always goes to the first element, so iron has a 3. Chromate is CrO4. You find it where? On your reference table. What page is it, Caroline? 7. Page 7. Look it up. Has an oxidation number of 2. Parentheses. Bring your 2 down. Bring your 3 down. And you'll know it's A. Okay? Now, number 12. See how it uses that IUPAC crap? Okay, don't let it throw you off. All right, is lead in group 1 or group 2? Is it neither, right? Is it zinc, silver, or aluminum? No. It tells you it needs a Roman number. Okay? That's why I pointed that out to y'all. It's going to need a Roman number. Does it have, is it all nonmetals? Can't use a prefix. Okay? As soon as you see this is a metal, okay, no prefixes. Okay? Can only use old system if there's no metals. So no prefixes there. That's going to rule out D. So nobody picked D, right? Or you understand why you can't use it?
Yeah.
So, what's our answer now that we know we can't pick D?
C.
The answer is C. Why did we pick C?
Because oxide has two.
Okay, oxygen has a 2. That had a -2 oxidation number that should be there, and it's not there, correct? So what happened to it? It's simplified. So remember, multiply that through. So Pb2O4. So it's lead 4 oxide. I love questions like that. See if you remember stuff that was reduced. Yes, ma'am.
Yeah, that's the part I forgot. I mean, I guessed right, but that's how you tell if it's not.
Check your second element to see if it was reduced.
So you look for the chart of the second one, and if it's down there.
Yep. It'll probably be something like oxide, sulfide, chromate, sulfate, carbonate, something that's going to have an oxidation number of a 2. All right, what's true about the melting points of ionic and molecular compounds? Molecular is a word that Lolly and Caroline asked about yesterday. Molecular just means covalent. That's what that means. What's true about ionic and covalent compounds? If I give you that word, does that help us answer the question? Are they similar, first of all? Are ionic and covalent compounds similar in melting point? No. So A is out. All right. Melting points of ionic compounds are lower than the melting points of covalent. Who's lower? Covalent is lower. So B is out. Okay. Ionic is always going to be higher. Melting points of ionic and molecular compounds increase with the number of atoms present in the compound. People always tell me they like C because it sounds smart or scientific.
Yeah, I almost chose it.
People like that one. Sounds really smart. Please, 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 please do not pick answers based on stupid reasons like that. If it sounds like something we never talked about, we probably shouldn't pick it because it's not right. All right. The melting points of ionic compounds are higher than the melting points of molecular compounds is the answer. Okay. Now, there will be a couple things on the test that we didn't talk about because they're topics we didn't talk about, not because they're reasons we didn't talk about. All right. Which pair of elements is malleable and able to conduct heat? What does malleable and able to conduct heat mean? What does malleable mean?
They can bend.
Can bend. It can be rolled flat into a sheet. All right. So what type of elements are able to do that? Metallic. No, it's good. All right. So what's the answer? D is it. They're the two metals. The others all have a non-metal in there somewhere. All right. Number 15. All right. Who has the most similar properties? What do we look for?
Same group.
Same group. Similar properties has to be in the same group. Who's in the same group? B is the right answer. All right. Strongest attraction for electrons. I had this in the opening the other day. This one should be an easy one based on that. F is right. This was
That electromagnetic.
electronegativity. So it increases and decreases. Ionization energy increases, decreases. Radius decreases, increases. Make sure you know those basic ones.
Remind me to ask you a question about something.
Ask. Just ask why it's fresh. What?
You remember how we have to count, somewhere over here we start going down here.
It's a shorthand electron configuration.
Yeah.
Okay. Somebody remind Almija I got to do a shorthand electron configuration. All right. What occurs when energy is removed from the liquid vapor system? All right. This was your question from yesterday. Yeah.
You want me to tell you the answer?
Yeah.
I said A.
Y'all agree with her?
Because, I mean, it's maybe wrong, but I said,
You're giving us the face.
like when there's more energy, it makes it evaporate more.
Mm-hmm.
So when you take away the energy, it can't evaporate, it starts to condensate more like now.
Mm-hmm.
So,
All right. So if we remove the energy, all right. So we got a liquid vapor system. All right. It says we remove the energy. So what's going to happen to the water? It's going to do what? Is the water going to move faster or slower? Slower. So what's going to happen to the rate of evaporation? Okay. Rate of evaporation is slower. So if it evaporates slower, what happens to our vapor? Do we have more or less? We have less vapor. All right, less vapor. So what happens to my rate of condensation? Okay, so my rate of condensation slows. So if I have less condensation, what happens to my amount of water? Okay, so I have more water. All right, so now based on everything you just said, was A right?
Yeah.
yes, it
Yeah, it is. I agree. You with me, Lolly, or are you just praying for 9:55? You're here? Okay. You having a bad day so far? Okay, it's early. Okay. All right. So, which best explains the relationship between heat, energy, and temperature? Which one y'all like? I hear two B's. I got yeah, nodding yes. At least I got something out there going on. I got Karina nodding yes. All right. So, why did we rule out some of the other answers?
And the first one says, heat energy increases, temperature increases, and it freezes. That makes no sense.
Okay. So, if we freeze, we change from a liquid to a solid. All right. Can I increase the temperature? Meaning, can I add heat here and change into a solid?
No,
No. It's correct. It does not make any sense. Can't do that.
I didn't use any scientific knowledge.
It just didn't make sense. Okay, we'll go with that. All right. Can I read? Secondly, the next thing I was going to point out is in a phase change, can the temperature increase in a phase change?
No.
No. So, can the temperature decrease? No. Temperature has to remain constant in a phase change. It has to be a flat spot. So if you think about your graph, it has to be flat. Okay? So it has to be B or C. Now, thinking about these lovely, I might get that erased sometime this week. All right, so if we change from evaporation as energy decreases, temperature remains constant, evaporation occurs. All right, so we're going from a liquid to a gas, and it says heat energy decreases. All right. when they say decreases, I'm assuming they mean that it's given off. I don't know what they mean by decreases. It's just wrong. The answer is B.
Is it right to think that it gets colder when that happens?
I guess.
'Cause that's what I'm.
Yeah, I guess it does. I guess that's the way I would have looked at it too. I mean, it's getting colder and it doesn't, when it evaporates, it gets warmer. All right, what should that one look like to you? What does that look like? Might be
Math.
that we've done. Math, okay. What kind of math?
Annoying math.
Annoying math. Now you sound like Lolly. She's even nodding yes.
Something off the blue chart.
Something like the blue chart, okay. What off the blue chart? Who? Warm. Very warm.
What did he say?
He said specific heat.
Just find a Q.
Huh?
Oh, is it finding
It is finding Q. Which Q?
Q? Is it altitude?
Oh, wait, no.
I gotta find somebody that's excited in here. It's probably only me.
Yes, 'cause you don't have to take it.
No one
That's
is
true.
excited about chemistry. This
Oh.
is a student now.
It says melt, and there's no temperature change.
Oh my God.
Oh my God! It ain't even fourth period yet. Yes.
Is H
Heat of fusion. Very good, Karina. Q equals MHF. Okay? Thank you for the time update. I needed that.
You're welcome.
Okay? So Q equals, what's the mass? 16.5. Y'all better not make me suicidal when I get my scores back. All right? Times what's HF?
334.
334. Where'd you find 334?
First page.
So you look on the first page and you find HF. Now, when you multiply that, what do you get? Some giant number, which is 500 or 5,511. Now, can you find the answer?
I didn't even.
You didn't have to.
You know what? I don't care. We pick one.
I just saw,
Yeah.
picked out fusion. And
It's
then-
on there, and it has-
It's not asking you to actually calculate. It's asking you, why does it require this amount of energy? Okay? It's because you need 334 joules of heat. All you had to know was that you need the heat of fusion equation. And when you look up HF and you find out it's 334, you know the answer is B. All the question's asking you about is, do you know what formula to pick? And do you know what constant to use?
No, I don't.
Clearly you do not.
You know what? I don't care.
I got it right. Somebody put it.
What?
You're welcome as well.
Does the graph look familiar?
Yeah.
Yes.
Fabulous. At least it'll look familiar when you pick the wrong answer on Monday.
Yep.
Phase change.
You said it. I just agreed. You said
And so, the freezing point of the substance is at negative 20. Because the latent heat energy is absorbed by the substance as it's converted from a liquid to a solid, pick the answer. Which one did you pick?
D.
All right, I got A, B, and C. Did anybody like D? Oh, that's good.
No.
All right. A's done.
Is D the right answer? Is D right?
D is not right.
Okay, I
I'm
was
just
like,
making sure. I can't tell if you're being sarcastic or.
Where I'm
Yeah,
not
you
too
do
serious
that.
with it now.
I just- I didn't know what latent heat energy meant, but I saw that.
Since they're asking us about negative 20, first of all, where is negative 20? Let me move this back up a little bit.
On the graph.
Really?
Right here.
That's not wrong. Yeah.
What's happening at this point on the graph?
Phase change.
From a what to a what?
From a
Liquid to
solid.
solid.
Okay, from a liquid to a solid. Or a solid to a liquid, either direction. We know it's melting and freezing. Now, So if we know that, I got too many E's in there. So if we know that, let's look at our answer choices and see if there's something that doesn't go with melting and freezing solid to liquid. Because if there is, then we can chuck something. Do any of those things not say that?
I don't like these.
No. So it doesn't appear we can get rid of that. Now, the first thing we should know is, thinking back on the graph that we did, since it's a flat spot, is kinetic energy changing or potential energy changing? Potential. Kinetic, the graph has to be going up or down because temperature changes, right? So, kinetic energy is here and here. Those are your kinetic energy spots. So, potential energy is a flat spot. Kinetic energy has to have temperature going up or down. Kinetic energy is based on temperature changes. So that means which one of those answers can we chuck? C and D are gone because of kinetic energy. Okay? So get rid of those two. So now we're left with A and B. All right? So it says that we're freezing. This is where we have to fall back on that god-awful thing about where is heat absorbed or released. So if we go, we're freezing, right? So freezing, we start at a liquid and we change into a solid. So do we need these particles to speed up or do we need them to slow down? So do we need to absorb the heat or give the heat off? We need to give the heat off. So it's got to be what?
B.
It's got to be released, which makes it B. That's why it's B. It is B.
Wait, so release?
Released means it's given off. When you need it to cool down, when you need the heat to the particles to slow down, it's got to be released. Yep.
Not absorbed is when it gets hotter.
Absorbed is when it gets, you want them to go faster. And you need the particles to speed up. And given that there are this many of these things released, you could tell that people really didn't do well on these on the release test questions.
Yeah, well, it's fun.
All right, so here we have a graph. It says if 50 kilojoules of heat are removed from the substance when it's at 50 degrees Celsius, what will be the state and temperature of the substance? All right, so I got to go back up because I can't see it. All right, so 50 kilojoules of heat is removed at 50 degrees Celsius. So 50 degrees Celsius. All right, 50 degrees Celsius is here, right? Read over to this. And we're at what? 200. I think this is the weirdest question in the test.
Don't you just subtract?
Yes, you do.
Wait.
All right. I just think it's an odd question, but it's just me, I guess.
B.
All right. So you take 200 kilojoules once you find it. You subtract the 50 kilojoules that they give you in the question, and you get what? You get 150 kilojoules. Now, you have to find the 150 kilojoules on the graph. Okay, so 150 kilojoules is here. Go up to the graph, and you're here. So, what state is that based on what we know?
Liquid.
It could be a liquid or a solid. And what temperature are we at? Okay, it could be a liquid or a solid at 10. So now check your answer choices and see which one they have.
It's D.
They only have a liquid, so it's D. Okay? I just think it's a really weird
If we
question.
don't know how to subtract and do all that, can we just say that if it decreases by 10, it's still going to be on the same line?
It's fine. I don't think you'll see one like that on the exam personally. I just think it's an odd question. There's a reason that question got chucked. All right. This one. What should jump out at you to solve that question? All right. It's got standard temperature and pressure. And it's got what in it? How many what? What formula should come to you? If it wants moles,
NRT.
PV equals nRT.
Oh.
Okay? So PV equals nRT. Pressure is 1, volume is 135, moles we don't know, R is 0.0821, temperature is 273. Now, we're going to multiply 135 in 22.4. All right. Let me get rid of these parentheses for Lolly. Lolly.
Yes.
It's the opposite of multiply. Does that make sense? Okay, that's what you're going to do tomorrow or Monday. See, it's not supposed to.
Yes, it is.
So now call for freezing rain.
It's,
Whatever.
I heard Miss Cross and that, what's the gym teacher name? Not Coach Mormon, but the big one.
The big who?
The big fighter.
Henderson?
Yeah, him. Him and Miss Cross was talking. Mike? He said it's supposed to snow.
The Weather Channel's not calling for freezing rain.
He said snow everything.
It's gonna freeze it.
I didn't even.
Miss Cross said,
It
oh
was
my, I
30
hope
this
it
morning.
does.
Huh?
It was 30.
I don't even.
That's what she said.
It's cold now. It would
Okay.
It's like 20
But
something
then,
degrees
no, but
outside.
then it gets warmer. The ground has to be a certain temperature for anything to stay there.
I don't think we have a good chance of snow. All right. What should this look like to you if you see it on the exam?
Yeah.
Oh,
It should be a really easy question. Is what? Yes, very good, Jada. All right, this should be PT equals P1 plus P2 plus P3 plus dot, 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 dot. All right, now it wants to know what is the partial pressure. So somewhere in here they told us the what? The total. So they said if the total pressure is 11.20, all right, the partial pressure of NO2 is 1.25. The partial pressure of CO2 is 2.63. What is the total pressure of SO2? So what do I do to solve? Add the two and then subtract. All right, so 11.20 equals 1.25 plus 2.63, 3.88 plus P3.
Are you okay?
is going to bust open.
Yes, you were.
They were a lot nicer than you are. 'Cause we're gonna have to convert anything.
Nope. The state test is much nicer than I am.
Thank God. Like, I remember we had to convert. I swear we have one question where we had to convert every single one.
Yeah.
When I was doing it, I was like.
Yeah. All right. If we look at this one, what can you tell me about the potential energy diagram? All right, I hear exothermic.
That, which means it's negative.
All right, delta H is negative. I like all that information. All right.
Yeah, you take this.
What's Y called?
The EA.
Good.
What is it called?
What's Z called?
EA reverse.
EA reverse. Good. Now tell me the answer to the question.
Exothermic. When exothermic reactions really give off heat,
Yes.
so they're like hot.
They're going to feel hot to the touch. Yes. They'll feel hot to the touch. So if it describes it, it will feel hot.
That's what we didn't mean. Like, that's why I don't even know it's extra.
Oh, something that just popped in my head. I can't remember if I did. Let me point this out to you. If it has a,
I just said.
can we talk about that, adding a catalyst?
No.
Yes, I remember.
All right, if we add a catalyst, that's right. So if we add a catalyst, how does the potential energy diagram look though?
It like shrinks.
It shrinks it, okay?
When you put feel hot, what happens?
When it's exothermic, it'll feel hot to the touch. We did that way back at the very beginning of the semester. So Caroline was asking, so I was refreshing. All right, but if I add a catalyst, how does it change the potential energy diagrams? It goes faster, right? So it makes the activation energy lower, makes it easier to happen. So they might, if they show that, the way they'll state it is it lowers the activation energy.
When will there be a lot of consoles?
I don't know. I'm not feeling any love over there, dude.
I'm sorry, is this cold in here? I'm ready to go.
I can't fix the temperature.
I know.
Wait, the answer was it's
Let me see.
Yeah.
All right, so how does increasing the temperature affect collisions?
It makes them go faster.
It does make them go faster, so which answer is correct?
Yeah, that's A.
All right, so we got A. Do we agree with A?
Yeah.
I do too. All right, number 26. Which reaction produces lime water? We only talked about this because I didn't have any to show you. And this was way back at the beginning of the semester.
Lime water, milky.
What?
I can only talk about it.
No.
I told you if you had clear water, it looks like water, and you blow into it, it would turn milky. So which one up there would be you blowing into it, and it would turn milky?
Wait,
C, because what do y'all blow out? Carbon dioxide. I just don't have any for y'all to illustrate. We would have done it when we did the chemical reaction lab the first week, but I didn't have any to let you use. Okay, it would look just like water, and it would have turned like milk colored when you exhaled into it.
Is it, why is it called lime water? Does it have lime in it?
It's like limestone. Calcium carbonate is like limestone. All right, so I'm just going to tell you the answer here is that, and the answer was that. And if you got it wrong, please don't tell me.
Please tell me. We only do it on the first week.
Don't want to know. Now, number 28. What type of reaction would that make? Very good. It's two compounds.
So double displacement is two compounds.
Double displacement is two compounds.
Single displacement is an element and a compound.
An element and a compound, yes.
One element and a-
One element plus one compound.
Does it have to have a compound?
It has to have a compound, yes.
And if it's just elements, it's synthesis.
It's synthesis. Yes.
Okay.
All right, number 29. This is pretty standard. Take a sample of moles and go moles to grams. Are we ready? No kidding. Tomorrow I'm just staying home. I'll just do the best you can. 1.
Can you get us this close to example?
What difference does it make?
I don't know. I would figure they would care, but I guess. Oh. We missed it.
All right, so I get 35. Where do I put the 35? And then we multiply and we get D.
So just a question. If you have elements, like the same element, but spread out in like different compounds or whatever, you just combine them?
Sure. I mean, you can do them separate or you can combine them. It's your option. I mean, I would combine them just because it makes it faster, but you don't have to.
Like
Are you sensitive to smells?
Not really. Why?
It smells
It
like
kind of
butt.
stinks over here.
Well, then spray it towards them. I mean, not crazy about it. That's plenty.
That's good. Thank you.
if there's like a compound you can use to separate from that too.
Yes.
Right, a whole bunch.
All right. So, in number 30, you have stoichiometry.
You smell it? I can smell it. Yeah, but that thing smells like water.
There's cherry blossom.
Right.
It smells like.
So, whichever one of you farted over there, could you stop?
Wait, Jen, who smelled it too? It's not over here, because Jay smelled it too, and it made
I
me
don't
like.
smell it.
So whoever
I just
farted,
don't-
stop.
All I know is.
Moving on, number 30. So if you have moles and you have to go to moles, set up your chart. Guys, shut up. A few people do want to review. The rest of you, if you do badly, you get what you get. I will not help you. 7.2 moles of oxygen. What goes on the bottom? Moles of oxygen. All right. From there, are we changing compounds? Yes. It asks for moles of MgO. So we put moles of MgO on the top. Where do the numbers come from when you go moles to moles? The problem. You've got MgO here, and you've got oxygen here. So what coefficient is in front of MgO? 2. And in front of oxygen? 1. So you get 14.
Do you think they'll balance all the equations?
Don't know.
What's your best guess now?
My best guess is probably.
Probably not.
Probably. I mean, I'd say look through the most recent version that I'm going to give you tonight and see what they have.
Is our test an honor version or standard?
It's honors. Most schools don't. Well, some schools teach a standard version, but not a lot do. All right. Why does the rate of a chemical reaction increase when the surface area of the reactant is increased?
B.
B is correct. Okay. If you increase the surface area, there's more area for collisions. All right. Number 32. All right. This is the one I just talked about a second ago if you were listening. Which best describes adding an enzyme to a chemical reaction? Okay. Lowers the activation energy. That's why I pointed that out. So if you have, let's say you have the endothermic reaction, even if you add a catalyst there, it's still going to lower your activation energy. Okay, so this is the one that's with a catalyst. Okay, it makes the energy less. And for those of you who are perpetually late, because that's usually the example I use with this, try not to be late on exam day, or if you are late, and sometimes I get someone who gives my exam, like Miss Love comes to mind. Miss Love is not someone who gives you time to be late, okay? When I give the exam, if I know, then I'll ask the class I'm giving the exam to, are there people who are perpetually late? And I'll usually give those people time to get there. Miss Love, for example, not one of those people. When she gets here and she reads the instructions and she's ready to start and you get here late and she started, you come on makeup day.
Well, Ms. Love better find something to do with her life. Diamond.
You've been early.
You've been on time every day for 2 weeks. You can be on time on exam day.
I just ran.
But you were still here.
You were still here.
Okay.
Okay? Okay? Be on time on exam day. You can be late the first day of second semester.
I don't want to start off the session looking like that. I probably will.
I'm just telling you. Some people are not as kind about waiting for people to get here. Huh? I do have no idea. They said in the training session that it was more departmental this year, less outside of the department, but I don't know. All right, so when you look at the equation, can we write K? This should be pretty easy. Who has to go on the top? The product, so it has to be NH3 on top and H2 and N2 on the bottom. So that only leaves us either A or nobody. So it has to be A because the reactants are on the top of everybody else. So that should be A. All right, 34 and I think it was 35 are both shifting equilibrium. So a sample of ammonia, blah, blah. It says after equilibrium is established, the container is opened, allowing NH3 and HCl to escape. So if this is escaping, that means that we're removing these. So if I'm removing it, equilibrium has to shift to which side? to the left. It has to go to the same side. So equilibrium is shifting to the left. Okay? So if it shifts left, what's going to happen? This side is going to increase. This side is going to decrease. So, would I produce less NH3 and HCl? Nope. That's out. The reaction would shift to the right. Nope. We just said it was going left. The reaction will shift left. So it's going to be that. Number 35. We did not do this. Okay, don't worry about Arrhenius. That's just your standard base. To be an acid, we start with hydrogen, which you know. To be a base, you end in OH. Okay, that's real simple. If you start with an H, you're an acid. You'd be an Arrhenius acid. If you end in OH, you're a base. So if you make hydrogen ions, you're an acid. If you make OH ions, you're a base. So which one of those would be the Arrhenius base? D. Why wouldn't it be what? Because hydroxide ions on your reference table have what oxidation number? That's why. Okay, number 36. Now, to do this, you need your reference table. You need your math formulas on the formula sheet. Now, this is just a way to help you eliminate some answers. This is a topic we didn't get to. There are 6 formulas on this page that we didn't get to. They all go with the same topic. The question is asking you about pH, right? Find your formula for pH. The formula say for pH. pH equals what? Of? Okay. Now, you don't have to use logs. Don't freak out. You're going to use a button on the calculator. All right. It says, what indicator would appear to be yellow in the solution if you have a hydrogen concentration of 1 times 10 to the negative 7? So we're going to put this number in this spot. So pH equals the negative log of 1 times 10 to the negative 7. Now, you don't have to put the parentheses in. I'm just showing the number where the H goes. So you're going to take your calculator, and you're going to put the number in exactly as it appears. I'm going to put my calculator. There it goes. All right, so negative button, log button, 1 second, negative 7. Are we participating or not? I can see. That's a lot of participation out there. Negative, I know, I see that you are. Negative, log key, 1 second, negative 7. Now, hit equals. What do you get? 7. You get a 7. Now, once you get that, now you just have to translate it into the chart. All right? And wants to know which one of those indicators would give you that color range. Well, you have a pH of 7, right? So now look at the ranges and see where 7 fits. It's C, it's phenol red. Okay? But you had to find the equation that would fit with pH because it gave you a pH question. Does that make sense?
So will we ever use the POH log?
If it gives you a question that asks about POH, hunt for the POH question or equation. The equation works the same way.
I don't see any other POH questions like
They didn't have a POH question on there. It might be on this one. It would work the exact same way, though. You'd say negative log, and you just get a POH answer. All right, electrolytes and non-electrolytes we did not do. Guess B and move on. The answer to this question, basically electrolytes conduct electricity and non-electrolytes don't. Okay? These conduct. These don't. These are ionic. These are covalent. That's probably the shortest synopsis I've ever given in my life. Okay?
Wait, so.
Electrolytes are going to conduct electricity in water. They have to be in water. Covalents are generally non-electrolytes. Ionic compounds will dissolve in water and create electrolytes. Covalent compounds dissolve in water and they're non-electrolytes. So,
And do not.
they do not conduct electricity. Okay, so when you're hunting for answers that are going to be electrolytes, things that are electrolytes are ions. So like Gatorade, Powerade, they create ions. Swimming pools are filled with ions. We dump chlorine compounds by the buckets in swimming pools. They make moving ions, okay? Those create electrolytes. So when you read the question and you're looking for something that's an electrolyte, you're always looking for the words ions in solution, okay? Because they come from ionic compounds. So acids would be electrolytes. Bases are electrolytes. They make ions in solution. So which one would be the right answer? Let me look. Electrolyte solutions produce ions in solution, while electrolytes do not produce ions in solution. It's that one. Electrolyte solutions include alcohols and sugars. No. Electrolyte solutions are not able to conduct electricity. No. Electrolyte solutions are not composed of polar solute substances. No. It's A.
So all acids and bases are ionic.
All acids and bases are not ionic, but they dissolve in water and make ions. We'd have gotten there if we had time, but 6 days killed us. All right, there's a solubility graph. At 50 grams, at what temperature will 50 grams produce a saturated solution when dissolved in 100 grams of water? All right, so you'd have to do 50 grams and then find the temperature. So 50 grams over and find. So 50. What did we get? What did y'all get when you did that? 54? All right. Because I went too far. Right there is where my eraser's sitting. You got it? Okay, 54. All right, next one. Another solubility graph. I don't know why people must have got these right because these couldn't have been hard. All right, which solution contains 50 grams at 80 degrees? And figure out what it is. 50 grams at 80. All right, 50 grams at 80 would be there. So it would be what? Saturated because it's on the line. Okay, everybody got it? My eraser's sitting on it.
That's A.
Yeah, A. Where am I at? 40?
Yep.
All right, I got 5 minutes. We can do this one quickly in 5 minutes, and we'll have all the answers done. All right, this one's not hard if you follow your oxidation numbers. All right, a chlorine ion is what? Okay, it's asking when salt is dissolved in water, what happens to the attraction between the salt ions and the oxygen atoms in water? Think about your oxidation numbers. A chlorine ion is what oxidation number? -1. Okay, so it's negative. Is attracted to the partial negative charge of an oxygen atom. Oxygen is a -2. All right. Is it going to be attracted? All right. Chlorine attracted to the partial negative of an oxygen. No, negatives don't attract negatives, do they? So that's wrong. All right. So now think about what you know. Is chlorine, which is negative, attracted to the partial positive of oxygen? Is oxygen positive? So that's out. All right, sodium. Sodium has what oxidation number? Okay, so sodium's a +1. Is it attracted to the partial negative of oxygen? Yeah, positives attract negatives. That's probably it. Sodium is positive. Is it attracted to the partial positive of oxygen? No, because it's not positive. So the answer is C. Okay? Now, this is the most recent thing I have. And I just literally found it at 8 o'clock this morning. Apparently the state released this year 40 new questions that are supposed to be like what you should see Monday. Okay? It's not even been shrunk. So it's legit full size of a test. I haven't even looked at it, so my homework tonight is to do this test too.
Do you know where the answer will
I have the answers, I haven't even looked at the answers.
Could you post them on the website?
If I get a chance today, I've got to cover everything in here.
Like just before the weekend?
They will be posted before the weekend, I promise. One for donation. Okay? Now, I would really, really, really like you to do these tonight. I know what asking that is probably going to get me. That's what I would like.
Yeah, we did have a problem.